Alright, it's section 6.5, and here we're going to learn how to solve linear inequalities using multiplication and division. Before we actually do that, let's take a look at this investigation. I want you to look at these four inequalities, A, B, C, D, and I want you to do what it says. And then I want you to compare the resulting inequality and tell me if it's still true or does it become false. So, if you look at part A, I'm asking you to multiply both sides by 4. Negative 3 times 4 is negative 12. 5 times 4 is 20. Is negative 12 still less than 20? You bet. So this is true. How about part B? Now 4 is being asked to divide by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. I'm going to keep the sign the same. Is 2 bigger or equal, or greater or equal to 1? I think so. True as well. Part C says multiply both sides by negative 1. So I'm going to take negative 5 here, and I'm going to compare it with negative 7. Here I'm saying negative 5 is less than negative 7. Is that true? I don't think so. False in this case. Remember that number line. Here's 0. 1, 2, 3, 4, 5. Negative 5. Negative 7. Which one's further to the right? That's the bigger number. Negative 5. So this one's false. And then 10 divided by negative 5 for part D. That's negative 2. 15 divided by negative 5. That's negative 3. Is this true? Negative 2 less than negative 3. I think this is also false. So we've got problems with C and D. Which questions gave you true statements? A and C. Oh, sorry, A and B. Which ones gave you the problems that were false? C and D. So what happened with C and D? Why did those become false? What were we doing? What operations were performed? Well, we were multiplying or dividing, but in C and D you were multiplying or dividing by a negative number. Where in A and B we just multiplied and divided by a positive number. So, what do you conclude? Well, multiplying or dividing an inequality by a negative number creates a false inequality. No good. Why? Well, when you multiply or divide by a negative number, it changes the sign, and therefore the inequality does not make sense. Think of a number line again. Look, here's 0, 1, 2, 3, 4, right? These numbers here are positive, like 2 and 4, but once you divide by a negative, notice how the signs change, right? Now we have negatives over here, so even dividing by negative 1, the 2 becomes negative 2, but the 4 becomes negative 4, and now look at which one's to the right. Look at which one's bigger. It's the opposite. So, key thing here. If you're multiplying or dividing both sides of an inequality by a negative number, please switch the sign. Okay? It's in the box. It's a caution. It's starred. It's important. Okay? So let's try some examples now. Solve the following inequalities, and then I want you to sketch your solution. This one is 4x plus 1 is less than or equal to negative 3. So just like how I solve an equality, I try to isolate x. I'll subtract 1 on both sides, so 4x is less than or equal to negative 4. In this case, I'm dividing by 4, not negative 4, just a regular 4, so I don't need to actually switch the sign. So x is just less than or equal to negative 1. And once again, here's negative 1, solid dot because there's an equal sign, and less than going to the left. Notice I did not have to switch the sign because I was dividing by a positive number. Over here, I guess my first step should be to add 5 to both sides. I still have k divided by 2 on the left, and now negative 1 plus 5 is 4. K divided by 2, so the opposite of dividing would then be multiplying by 2, so I'll times 2 on both sides. K over 2 times 2 is just k, right? And if you didn't like how I did that, remember it's k over 2 times 2, or 2 over 1, so that's why the 2 disappears. And 4 times 2, of course, is 8. So in this case, k is greater than 8. And open dotted 8 going to the right. Notice in both of these examples, we did not need to switch the sign because I wasn't dividing or multiplying by a negative number. Okay? So let's turn the page. Now in part C here, I see we have equations, or sorry, an inequality with variables on both sides. You can choose which side to move your x. It's up to you. I'm going to actually just subtract 4x because I like having x's on the left hand side. So 2x minus 4x is negative 2x minus 6. That's greater or equal to 2. Now I can continue on by just adding 6 to both sides. Negative 2x is greater or equal to 8. Notice here now I'm dividing by negative 2. And so when you're dividing by negative 2, here you must switch the sign. So instead of it being greater than or equal to, we switch it to make it less than or equal to, and the answer is here. Less than or equal to negative 4. Now, let me just do this one again. If I didn't actually move the x's to the left side, and instead I wanted to keep the x's on the right hand side, notice what happens with this now. We'll subtract 2x on both sides. Negative 6 is now greater or equal to 2x plus 2. We'll subtract 2 on both sides. Negative 8 is greater than or equal to 2x. And then now we'll divide both sides by 2. And notice I'm dividing by a positive this time, so there's no need to actually change the sign. But this one does read a little bit differently. Reading from left to right, I have here negative 4 is greater than or equal to x. So that number negative 4 is the largest x could be. And that's why you're still going to be shading to the left. Okay? Or if you read it backwards, going like this way, x in this case is less than or equal to negative 4, which is exactly what I wrote over there. Okay? So just be aware. Like I said, I prefer having the variable on the left, but if you want to keep it to the right, just be aware that it might look a little bit different and you might need to read it a little bit different. Okay, D. Well, brackets, so I guess we should get rid of them by distributing. 3 times 4, that's 12. 3 times negative 2x, that's negative 6x, is less than 2 times x. 2 times 3 is 6, minus 2. In this case, I'm just going to collect like terms. So 12 minus 6x, in this case, is still less than 2x. And then 6 minus 2, that's 4. Now this looks like a question in part C. So up to you what you want to do. Once again, my preference is to collect the x's on the left hand side. Negative 6x minus 2x, so that's negative 8x. Less than 4. Once again, I want to isolate the x on the left, so I'm going to subtract 12 onto both sides. Negative 8x, 4 minus 12, that's negative 8. And then finally, to solve for x, not negative 8x, I'm going to ask you to divide everything by negative 8. So x now, and whoops, dividing by negative, switch the sign, greater than 1. And therefore an open dot at 1 all the way to the right. Okay, once again here, I switch the sign because I'm dividing by a negative number. Okay, then there's E and F. So, fractions, ew, decimals, ew, but we found ways to eliminate them. I hope you still remember from our previous studies in this unit. So, fractions we hate. We can get rid of them or rewrite the equation by multiplying by the lowest common denominator. The lowest common denominator between 2, 3, and 4. Did you say 12? I think so. So the lowest common denominator is 12. So I'm going to ask you to multiply everything by 12 then. Okay, 12, 12, 12. The first one here, 12 times 3 divided by 2. 12 times 3 is 36, divided by 2 is 18, so 18a. 12 times 1 divided by 2, that's 6, so plus 6. Still have the less than sign. This one's a little bit trickier, but I don't like dealing with big numbers, so I'm just going to divide them first. What's 12 divided by 3? That's 4, and then take the 4 and multiply by 7. 4 times 7 is 28, so 28a. Then 12 divided by 4, I'm going to do that division first again. 12 divided by 4 is 3. 3 times 3 is 9. So this just becomes now minus 9. This looks like equation part C now. Lovely, lovely. So once again, my preference is to subtract from 28a and put the a's on the left-hand side. I know I'll get a negative here, but still, that's what I prefer. It's easier to read later on. Still have the plus 6 and the negative 9. I want to isolate the variable, so I need to get rid of the positive 6 by doing the opposite. Negative 10a is less than negative 15. We're going to solve now for a, so dividing both sides by negative 10, we get the fraction a is less than 15 over 10, or a is less than 3 over 2, if you simplify that. Right? You should be saying, wrong, because what did I forget to do here? Yeah, dividing by a negative means we switch the sign. There you go. Now we're good. Okay. F with decimals. You hate decimals? Multiply by powers of 10. Notice there are 2 decimals, or 2 numbers after the decimal place. That's 25 hundredths. This is 75 hundredths. 10.25, or 25 hundredths. So let's multiply everything by 100. So you get 125 plus 75n is less than 1025. Solving this now by subtracting 125. 75n is less than or equal to 900. And let's divide both sides by 75. Notice in this case, dividing by a positive number, no need to go ahead and switch the sign. 900 divided by 75. How about 12? Okay. So I hope you feel comfortable now with solving inequalities. This section actually ties everything together. Let's finish this off by just seeing how we can use inequalities. And here's an example. I don't know about your school, but our school has an athletics program, and they have a budget. In this case, it's pretty small, only $500 for an awards dinner. So the question I have for you is, if the restaurant that they're going to charge us a $50 setup fee, and then $20 for each person that shows up, how many people actually can attend the dinner? If at most we can spend $500. So think about the cost of the dinner. What does it entail? Well, it does entail some sort of fixed cost of $50. Right? That's like a fixed cost. And then how much? Well, it depends on how many people come, which sometimes we call a variable cost. Variable because we don't know how many people come. In this case, it's $20 for each additional person, or each person. So 20, and maybe I'll use n, that stands for the number of people. So always identify a variable. N is the number of athletes. So our cost here of 50 plus 20n is at most 500. Now, when I use the word at most, what symbol should I use? Is it greater than? Is it less than? Is it greater than equal to? Or less than equal to? Well, at most means that the biggest it could be is 500, but it can also equal 500. So this less than or equal to is the winner. So here's our equation, our inequality, I should say, because an equation is an equality. And now, how do we solve this? Well, this just looks like what we did earlier. So we'll subtract 50 on both sides. 20n is less than or equal to 450. We'll divide both sides by 20. 450 divided by 20. Ooh, interesting. 22.5. So we can invite 22.5 people, eh? Just half a person, not the whole person, but the half a person. That doesn't make sense. So I'll say at most, you can invite 22 athletes. Because it wouldn't be nice just to invite someone's left side and not the right hand side. Okay, so in this case, round down.